Hello, my name is Bob Tickleman. I'm an Azure Technical Trainer, newly formed role at Microsoft, and for the previous several years, I was a premier field engineer, most recently working with the Azure Stack team on the Early Adopters Initiative. I'm here to cover one of the modules in an ongoing series that we're presenting on Azure Stack. This one specifically is dealing with the integration points, both technical, organizational, and people-wise within your companies. A number of these are going to be introductory topics that will be covered in depth later on in following modules. For example, specifically the network integration components are covered at a high level here, but will be covered in an entire module later on. So what we're going to take a look at is what are those integration points. As I mentioned, there are people integrations, the roles that you're going to have to take on, what an infrastructure component is going to be, and as well as the business organizational processes that will need to be changed. When you take a look at the Azure cloud, that top line, Microsoft is responsible for the significant portion of the operation of the cloud services, and it's really there for consumers and our customers just to come and use those services. The physical infrastructure, power, networking, compute, storage, memory, services, patching, all that is going to be performed by Microsoft. If you take a look at that as opposed to the Azure Stack model, the bottom portion of the screen, users are still going to be developing applications the same way that they would in Azure, and I often say that as it exists in Azure, so it does in Stack. And so for the users, there's not much that's really going to change for them. And what you're seeing in the bottom right-hand corner is where the significant change is and why you're probably taking this course. Microsoft is still going to be responsible for managing the Azure Stack software portion of the implementation. A big portion of the physical hardware is going to be maintained and managed by your OEM vendor, but you still have to play an important role in the ongoing maintenance and support of the Azure Stack implementation in your data centers. And Microsoft has defined two specific roles to help clarify what those skill sets are and the activities that would be performed by the individuals, and we refer to them as the cloud architect, which will then be responsible for the overall design and goal expectation setting for the Azure Stack implementation. And then the cloud operator, which is more that day-to-day operation, performing backup activities, maintaining the availability of the Azure Stack itself, and the operational roles that go along with that. In a traditional environment, over the decades, this environment has become compartmentalized in many organizations. There are people that are responsible for storage, and their job is to manage all storage, whether it be storage area networks, managing the LUNs, the physical hard drives. You have security people that manage the security components. You get SQL people that manage SQL. You get the networking people that manage the networking. And there's a variety of different tools that are used by each and every one of these individuals to manage their specific implementations of whether it be software, hardware solutions, and trying to integrate them. And this is where a lot of specialization has come in. In addition to these myriad of tools, there's also going to be that responsibility of having some deep knowledge in specific areas, whether it be networking, storage, compute, identity in the form of Active Directory, directory services. And this has been creating silos of technology and people responsible for them with that deep level of knowledge. One of the nice things about a cloud solution and Azure Stack specifically is the API sets that are going to be common between the public cloud offering of Azure and the hybrid or on-premises deployment of Azure Stack. They share that common interface, the same API layer. There's a couple of nuances that will be different between them, but there's a common set of PowerShell that they're working with, APIs, REST APIs, and we'll be talking more about those as we get further into this course. Many of you probably have had even an evaluation or proof of concept of Azure Stack deployed to you in a thing called the ASDK, or the Azure Stack Development Kit, where you can actually get in and play with, in a non-production environment, a single node of an implementation of Azure Stack. The first thing you're going to need to do, though, is find a way to integrate it into your data center. So we'll take a look at that now and talk about some of the considerations. Now, a lot of this work will be done for you in conjunction with input from you that you will provide during development and deployment phase. So once you've selected your hardware vendor, they will actually fill out a deployment sheet with you, asking you a number of questions that will go through a series of these areas. But without the integration, Azure Stack itself is just going to be an island sitting there. It's not going to be communicating with your network. You won't have any identity specifically to log into until you fill out this sheet. So this is what we're going to be talking about. And I'm not going to cover the physical placement. This is something that's going to be needed to be discussed with your OEM to make sure that physical environments, floor structures, power, air conditioning, networking capabilities are all going to be met and delivered to be meet your requirements and the requirements of the physical infrastructure. So what you see here is a number of those integration touch points. The topics in red are those that you need to think about in advance, and those feed into the deployment process. In order to deploy an Azure Stack, as I mentioned, you're going to need to fill out a deployment worksheet with the vendor that will be used as input values during the actual physical implementation of the scale unit. And those areas that you see at the top row lead directly into the deployment sheet, and then will be part of that installation. The green areas are areas where you typically are getting into post-deployment steps. And we're going to dive into each of these areas to make sure that you understand what the requirements are and what would be needed for this step to be completed. The networking piece and the tying in of the Azure Stack Scale Unit, you saw from a previous model that a lot of the infrastructure is an appliance. There's the 2 top-of-rack switches, there's the BMC switch, there is the however many nodes that you have deployed, a minimum of 4. You've got the PDUs, or the power distribution units. But during the deployment worksheet, you're going to be asked a number of questions to provide the infrastructure deployment with what is going to be the infrastructure IP addresses, the storage IP addresses, the BMC addresses. These are all covered in module number 6 of this series of classes, and know that there'll be some gotchas along the way. And I want to point out just specifically the public IP addresses. You've got to be very careful with those, because you can add to the public IP address base if you don't have it enough, or give it enough, but you're not going to be able to take some away if you've given it too many. So this is going to be some consideration that you want to really have some guidance on and understand before you go through that process with your vendor. So now that you've got the scale unit deployed, you want to think about how do you connect the Azure Stack appliance into your existing network. You already know that the Azure Stack architecture sessions, as we said, talked about these top-of-rack switches, and how do we then tie those 2 TORs into our corporate network. You'll see in the slide here that there's the 2 boxes at the top, the boxes marked in red, border switches. We'd strongly recommend that you have a minimum of 2 to provide that fault-tolerant connectivity from the 2 TORs into your corporate network itself. But there's a whole series of networking infrastructure. Azure Stack internally uses a protocol called BGP, or Border Gateway Protocol, to provide the routing information within the stack. And you can continue to use BGP protocol up into the external network, or you can use a static routing if you wanted. While the details on this slide are covered in the networking modules, as I mentioned earlier, later on in the series, module number 6, it's meant to show that which logical and routed information is either kept within the scale unit or routes beyond the scale unit itself. In addition to the IP addresses, there's a number of other integration points that are going to be critical for you to consider. Time across a lot of Microsoft services is going to be a critical piece, and an NTP or network time service needs to be in place and will be a mandatory component for the deployment. As you see there, Microsoft has this Kerberos requirement that there is no more than 5 minutes, which is a default value, that no service can be outside of that time window, otherwise authentications will fail. Other important parts are things like the syslog server. Even though it's not required, when provided, we use this information for the configuration of the physical network switches and for the baseboard management controllers, or BMC, in the servers. Physical network switches in the BMC will then send log information to the specific syslog server. Azure Stack does not ship with an integrated syslog server, so it is important that you might want that information in an off-scale unit deployment. Device authentication, again, is not a mandatory setting. It is your choice to have that. Device authentication is supported for network switches and baseboard management controllers. It supports protocols RRadius and TACACS. Device authentication solutions are not part of the actual deployment. It relies on customer infrastructures to provide that capability for you. DNS is also going to be a critical part for name resolution, and what specific deployment or architecture you have for this will come up in Module 6 on the networking side. But you name your Azure region or your Azure Stack region, much like we do in Azure. If you're going to have a deployment, say in North America and one in Europe, you could have them in East North America versus West North America. Those become a region, which is a grouping of scale units in a physical location. We have to have an external name for the Azure Stack deployment and the ARM layer you're going to be working with. So you might have east.cloud.fabricam.com just as a name. That would go to the grouping of one or more Azure Stacks in whatever physical location East was. We then want to have an internal name, and so you see Azure Stack.local, and that's the name that is used by default, specifically in the ASDK, or the Azure Stack Development Kit. Deployment of Azure Stack. You want to have DNS forwarders so that names that are outside of the Azure Stack itself are going to be forwarded for internal name resolution or for public name resolutions itself. For security reasons, Azure Stack has 2 DNS servers with a total of 2 DNS zones that are shipped out of the box. The 2 DNS zones consist of an internal zone used by Azure Stack internal services. This goes into that star.azurestack.local name that I was talking about, and a DNS zone for external facing endpoints. These are going to be your private endpoints that you're working with. This is going to be any of the PaaS services you're working with, those public-facing services on the scale unit. But when deploying PaaS services and additional DNS zones that may get created, you then need to deploy those in there. For data center integration, the DNS zone for external-facing endpoints must be resolvable from the existing data center infrastructure. And Azure Stack DNS servers can be configured to resolve multiple DNS zones based on integration points. Typically, only the DNS zone used by the Windows Server Active Directory environment is going to be required. Again, for data center integration, it's important that your scale unit has this external DNS zone that can be resolved for data center network capabilities. It can use a wide variety of DNS resolution methods, conditional forwarding, delegation, stub zones, root hints, and conditional forwarding is used by the Azure Stack to resolve the customer's corporate DNS by default. There's also a graph component in Azure Stack that delegates permissions for a subscription. In production deployments of your scale unit, not the POC or the ASDK deployments, the AD graph enables users of the customer's Active Directory Domain Services, or ADDS, hosted identities in RBAC scenarios on the Azure Stack deployment. And you really need to understand that there's a difference between authentication, which is done by Azure Active Directory or Active Directory domain services, and then the authenticate or the authorization, which is the granting of permission to specific resources, which would then be done by RBAC. So what they're saying here is you can pass the authentication part off to either Active Directory directory services, or off into Azure Active Directory for the authentication, but then control the delegation of permissions using RBACs within the scale unit. AD Graph uses the LDAP protocol to look up users in the existing ADDS for us, and it uses some standard ports of TCP 389, 636, 3268, and 3269, but LDAP is currently not supported. There is user accounts that are going to be needed to run the AD Graph, and this user requires read permissions to whatever directory service you're going to be using for the authentication process. When you take a look at the supported forms of Active Directory directory services or your on-premises environment you're dealing with, you'll see that you need to be at least at domain levels and possibly forest levels of Windows Server 2012 or higher for that to be able to work and function properly. Now we take a look at the two different types of deployments, and from previous modules, if you've taken the ones prior to this one, you would understand that Azure Stack can be deployed in either a connected or disconnected mode. The connected mode uses identities from the Azure Active Directory environment for that authentication that we were talking about, whereas the disconnected environment will be then connected to your on-premises Active Directory leveraging ADFS. Azure AD controls access to the Azure subscription resources. Permissions on the Azure AD do not convey those permissions as we talked about previously. Those are going to be done by RBAC on the local server. From a monitoring perspective, Azure Stack is broken up into three major pillars: the Azure Stack software, the physical servers, and network devices. And each pillar uses a different protocol for its monitoring solution. Azure Stack does ship with a health resource provider, and this resource provider allows for events to be retrieved using the REST APIs. If you take a look at the Azure Stack storage solution, which is supported by Storage Spaces Direct, this health information is going to be exposed through that REST API. Physical servers, the monitoring exposes information on health of the hardware components such as power supplies, fans, CPUs, the memory modules, and this information is going to be made available through the BMC. You also notice on the slide this thing called an HLH, or the hardware lifecycle host. Some of the vendors will, or most of the vendors will actually be implementing an HLH, and there's specific security requirements around the HLH that will be covered in future modules. The network devices monitoring is going to leverage standard SNMP. Each of these hardware vendors are going to have a dedicated monitoring package for their monitoring platform. Microsoft does enable health monitoring for the Azure Stack by providing a management pack for SCOM as well as plugins for Nagios. If none of these two are used, the customer can integrate with the health monitoring solution using those REST APIs or PowerShell to pull the information into whatever services that they're going to implement into their data center. Monitoring of the Azure Stack is agentless, so no third-party agents are going to be supported to be deployed onto the scale unit. And monitoring the physical servers and network devices by third-party solutions need to be supported by your OEM vendors. The previous slide covered what can be monitored. This slide shows how the components in Azure Stack can be monitored. For example, for monitoring the software, we have the System Center Operations Management Pack, which you could download and use, as well as the Nagios plugins. This plugin is written in Python and leverages Azure Stack Health Resource Providers and its APIs the REST APIs for that. The HLH, or the hardware lifecycle host, vendor-specific capabilities are going to be deployed. And as I said, not all vendors support an HLH. For implementation of the Azure Stack, customers need to be prepared with certain certificates. We list, and these are documented in the link down below, and they change from time to time, so you may want to go and check this document and get the current requirements for your certificate generations that will have to be gotten from a PKI, or public key infrastructure, that you support. Looking again just at some of the certificates, the namespaces that need to be identified on those certificates, and you can see where we talked a couple of slides back about regions and the FQDN public namespaces that you're working with. Again, here's some more of the certificate requirements. Azure Stack does support various endpoints or virtual IPs for its infrastructure roles, things like the admin portal, the admin arm, tenant portals, tenant arm, the graph API sets that we've talked about. And each endpoint is going to be secured with access control lists in both the physical switch and the software-defined network stack. A DNS entry is going to have to be created for each endpoint in the external DNS zone for where the user endpoint is going to try and retrieve that IP address from. You'll have the choice to publish these endpoints for things like the admin ARM portal, or if you want, Key Vault, for example. Those will be up to the implementation team that determines to publish those or not. And know that there's also a whole series of considerations regarding to firewalls and where the firewall is implemented, and do we need to be able to speak through that firewall and how to open it up. Previous to the 1808 release of Azure Stack, the number of firewall rules that needed to be opened up to gain access to services were significant, specifically 27 rules per port and extension that you wanted to be able to work with. With the 1808 release, a feature called Extension Host was announced and made available that significantly reduced this number of firewall rules that need to be created down from 27 down to specifically 4 ports that were only needed now. So significantly reducing the amount of overhead. So I'd strongly encourage that at the time that you deploy, that you look at extension hosts. And as I said, for the vast majority of you, 1808 or newer is going to be able to support this. There's 2 major types of deployments that we take a look at. This one is going to show a typical service provider where maximum throughput is critical, and therefore an internet connection is optimized at for that connection speed. This also could be done for corporate environments, but is strongly not recommended. We'll come up with that one on the next slide. But in an edge deployment, Azure Stack is going to be deployed directly behind the edge routers, with or without a firewall in front of it. Typically, public IP addresses are going to be assigned to the public VIP pool and deployed at the time that the scale unit is configured. This scenario enables the user to experience a full self-controlled cloud experience, much like you would get in the public-facing Azure. We recommend that you do use a firewall device to secure your scale unit. However, it is not a strict requirement. The second option to deploy your scale unit would be to put it behind your DMZ or your perimeter network, keeping it completely separate from an internet-facing port. This is a typical enterprise type of deployment that you're working with. If public routable IP addresses have been specified in the public VIP for Azure Stack, these addresses logically belong to the perimeter network and require publishing rules for the firewall or for the primary firewall. If you're going to use NAT, although it's not recommended because of the overhead, you could use a NAT address translation for publishing those endpoints. For the endpoints to be fully controlled by users, this requires that the NAT rule be configured per VIP that contains all the ports that might be used by that endpoint. Another consideration is that Azure does not support setting up a VPN tunnel to an endpoint using a NAT in a hybrid cloud scenario. Another option to connect your network is using an express route, which is a dedicated MPLS network from one of the 31 plus providers that we have to your data center. You'll notice that there is no direct connections to a scale unit itself, but this is going to provide connectivity from the data center and the networking components that you configure for that to be able to connect directly to things like O365, public Azure, and this is just showing a single tenant specific scenario, or it can even work in a multi-tenanted environment that we could work from an express route connection. That brings us to the end of this module, and we've introduced at a high level some of the integration points and some of the challenges that you've had with on-premises solutions in the past, and how Azure Stack, as part of a hybrid solution, can provide an answer for solutions or challenges when Azure is not the answer for you. And that's what I often tell customers is, Azure Stack is not in replace of Azure. It's the answer for when Azure is not the answer. So if you have disconnected environments, or you take a look at island nations like New Zealand or Hawaii, you look at locations where connectivity is critical but is potentially at risk, drill rigs in the middle of Gulf of Mexico. So a wide variety of, as I said, scenarios when Azure is not the answer, Azure Stack is the one. And the considerations that we introduced in this module will be covered in depth in future modules.